Okay, everybody. I'd like to wish you guys all a nice good morning today. And we're going to work with this normal probability distribution again. So I hope you guys are doing well. And we're going to put some things together here. So let's take a look here. Okay. Here we go. So good morning, everybody. Okay, let's go to the iPad. See how this is going for us today. This is where our homework really left off, I guess. But I'm going to try to put everything together for us. Here's what I'm going to try to put together. Let's outline for you guys the procedure for how to answer these particular questions. And let's give you a setting. Let's give you guys a question here. So here's what we're going to do. I'm going to look at, here's kind of how I kind of word things. I'm going to say something like this. Okay. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Okay, now they're going to say, what percent of the population has an IQ score that is, let's see what we're going to do here. Question 1, we're going to say, is more than 90? That's question 1. Question 2, is at least, let's say is at least 120. Question 3, no more than 135. And then let's say question 4, between 90 and, we'll say between 90 and 120. We'll kind of do something like that today. Okay. Question 5, less than maybe 115. Question 6, we'll say we have between 90. How about this? How about between 115 and 135. And then let's do a lucky 7. Question 7. Okay, question 7 here is going to be the following. How about between? Let's do another between situation. Between 75 and 90. And I think I want to do 8, maybe lucky 8. How about less than 75? All right, here is a question here. It's an IQ question. So I'll give you guys a few seconds to maybe write some of that down, because that's a lot of verbiage there, a lot of language. And give you guys a few seconds with that while I set some things up here. All righty. So we're going to need the TI. Let's set that up too. Okay. All right, so let's go through and read this so we could do these things from start to finish, show you guys how this process works. Now, notice this is what's called a normal probability distribution question. And then people say, Mr. Judge, how do I know? Well, you know because you're reading that IQ scores here. What are they? Normally distributed. So that's a big tip-off, right? IQ scores are normally distributed. Now, here's what this means to me when I first see this. That means X is going to represent IQ scores. So whatever they say to you is normally distributed. Let that be your random variable X. And once you say, oh, okay, X is my IQ scores, they're normally distributed. And then you go down to read some more. What does it say? You read and you say it has a mean of 100. And you go, okay, what does that mean? Well, I'll tell you what that means. That means mu is 100. Continue to read. And a standard deviation of what? 15. So that means the standard deviation here is 15. All right, so you have a mean of 100. You got a standard deviation of 15. This is what we're talking about here. IQ scores are normally distributed. So everything that you guys have to do is set up right there. Okay, so this is kind of what we have going on. And I go, okay, this is a normal distribution question. Fine. You're going to have to follow a procedure. Let's write down the procedure here. Here's going to be step 1. I always tell people, draw a picture of the question. So here's my first step. Draw a picture of the question. And you go, what are you talking about? Go back to the question here. Here's my first question. Question 1, right here. They want to know what percent of the population has an IQ score that is, I'm reading right here now, more than 90. More than 90. This means X is greater than 90. Your IQ scores are greater than 90. That's what more than 90 means, right? If you said to you, how many of you guys in the room here are more than 90 years old, greater than 90, right? Bigger than 90. Now, that's not a picture of the question, though. But you have to know what the question is. So more than 90, here's the picture of the question. I'm going to try to do this. Here's my bow, ladies and gentlemen. At the center is 100. 90, ladies and gentlemen, where would 90 be in relation to this 100? Remember, this is kind of like the real number line here. Larger numbers go to the right, smaller numbers go to the left. And these are X values, by the way, because X represents the normal distribution. So we're trying to describe X being greater than 90. And you say, I need to know where 90 is, that reference. 90, ladies and gentlemen, is to the left, by the way, of 100. Because smaller numbers live to the left. Larger numbers live to the right. And then you say, but they want to know more than 90, right? This is X bigger than 90. Which numbers are bigger than 90? Numbers to the right of 90 are bigger. So what I want you guys to do with this picture is shade, ladies and gentlemen, the portion of the bell that corresponds to the x values being bigger than 90. Those values are to the right of 90. So this is what we're doing. And so if I go back to what they're asking, they're saying, what? Let me do this in red. What percent of the population has an IQ score that is more than 90? Ladies and gentlemen, what percent? Here's what they're asking. They're asking this question here. What percent of the bell is shaded? Have you ever played that game before? Say yes. Okay, now I'm going to give you a hint. My right portion here is 50%. The left portion, though, between 90 and 100, I really don't know. So I'm on the right track, though. We got to play what percent of the bell is shaded here, ladies and gentlemen. So here's my step one, and this is what I recommend people do, to consider. And now I'm going to give you the traditional step two. Step two, I'm going to say to you, convert your normal distribution to the standard normal. Distribution. So you're converting this x to z. Remember, z represents your standard normal, and x simply represents the normal distribution. These are our notes. X represents the normal, z is the standard normal. So you say, well, how do I do that? You guys already know. You're going to use the z formula here to do that, right? This is z equals x minus mu over sigma. This is the conversion formula. In this example, mu is 100 and sigma is 15. So you're really going to use, ladies and gentlemen, this formula to convert x minus 100 over 15. So we have to convert your normal distribution question, meaning the question they give us is always a normal distribution. And then we convert it to the standard normal. This is what you guys do. It's these steps here. But you say, well, how does this formula work? Here's how this works, right? You have to input an x value to determine the z value. So you have to put in a value of x to get a value of z. Now you say, where are the x values? See this over here? This is the normal distribution. These represent IQ scores. This is an IQ score of 90 right here, IQ score of 100, the mean. These are the x values that I have to convert. So I'm going to convert 90. I'm going to input 90 for x. Let's see what 90 becomes as a z value. So this means z will be 90 minus 100 over 15. Let's plug that in. Let's go to the TI, and you say, okay, TI, I want you to do the following here. 90 minus 100, and then you're going to divide by 15. Now, here's what you guys get. You get this number here that goes on forever. Okay? I want you guys, for z values, you always approximate to the nearest hundredths. I'll say it again. Hundredths. Okay? The nearest hundredths. That's what you guys approximate to. So in this case, z is a negative 0.67. Okay? Because of the nearest hundredths. And I'll explain to you in a second why you do that. But okay. So then you go back to the iPad and say we got this z value to the nearest, again, hundredths always. Negative 0.67. And so 90 became, here's what I'm going to do. I'm going to erase this. You guys have that already. It's in the video. This here, as a z value, is negative 0.67. So 90 as a z value is negative 0.67. All right. That's one value we have to convert. We now have to convert 100 here. This value, the mean. Now, if you're awake, tell me what value 100 becomes as a z value. Well, we say now we got to plug in what now? What do we plug in now? Not 90. Well, let's keep that just in case. And you plug this in. Z is 100 minus 100 over 15. So this is going to be 0. So z is 0. So the mean becomes 0. Does that make some sense? Let's think. Let's think about this. My z value becomes 0 here. Thank you, Cindy. Right? Yes. Now, this makes sense. You guys know why this makes sense? Because what does z represent? Z is a standard normal distribution. It's supposed to have a mean equal to 0. If you guys remember the definition, mu is 0, sigma is 1. All right, there you guys go. So this is actually step 2. I call that the conversion step. So we have to convert here. All right. And then now here's my formal step 3, right? I'm going to do this formally for you guys and show you guys how to do this. Here's step 3. Here's what you guys are going to do. So, okay, let's double check. Step 1, yep. Step 2, step 3. Here's what I say. You're going to use the z table to determine what percent of the bell is shaded. So this is the game that we've been playing, ladies and gentlemen, for almost about a week maybe, right? This is where we actually started with asking you guys what percent of the bell is shaded, because this is how we do this. You already know 50% is right in here, right? This is 50%. But what you don't know is right in here. We have to find that value and add it to 50. Okay. So we know the right portion is 50%. The question is, what is in this left portion? Now you say, oh, Mr. Judge, you said use my what? My Z table. So to let you guys know, you guys will have your test on Monday. And I mean, we are big boys and girls here. I mean, yeah, we're dealing with a crisis, but you know, this stuff can help define you and lift you up in a way that you got to think about how you're going to prepare yourself to do things. Hopefully you guys know now how to scan. You want to scan, use that scanning software in your smartphones to scan your tests and, you know, and upload it to me. And some of you guys are going to even learn now again to do some time management. meaning you're going to have a set time to do your test. It's not a test where you take all day and submit it when you're done. Now, I want to say this to people now to get you guys ready. If you do that kind of stuff, I'm not going to grade your test. It's 0. Okay? So remember, be functional. You got to get your scanning software, the app in your phone so that you can take a picture of it and you batch, meaning all together, upload it to the proper place. So part of your test is going to be now to see how functional you guys are. Most of you guys are pretty good to go. Some of you guys, you're going to learn that lesson. So a lot of you guys are really just there, but some are not. So make sure you do those kind of things. Now you say, what does this have to do with my Z table? Well, because I'm going to let you use the Z table on your test. Okay? And you say, well, where do I get the Z table, Mr. Judge? Go back to the browser. And you say, oh, the course is Math 227. And I got a formula sheet, formula card. I might even put another one up called Z table. There's a Z table for you guys. Okay? This is the one we were using yesterday. Right? We were using this yesterday. You guys want to be functional to use this table here. So I'm going to go to the iPad now and say, okay, what would I do on a test? Well, iPad, let's go. Let's cooperate today, iPad. And I'm going to go out to that Word document. Nope, you guys are not calculus. One day you will be. Let's go to 227. And normal distribution right over here. If you guys remember, I was doing this yesterday. I'm going to have to go all the way down. I'll go all the way down to, if you guys remember, what percent of the bound. Right when we started talking about the Z, I had to click on this link, and I had my Z table here. I think I even have it in my, I have it on my, files here. So I won't use that. I'm just showing you guys here. Oh, got to go all the way to Z. So annoying. Probably 500 pages in this worksheet. That's a lot of work, ladies and gentlemen, just so you guys know. It's a lot of work here. So next time, note to self. There we go. Remember, this is what your Z table is good for the standard normal distribution. This is why I say this is what we use. Now remember, we're going to use symmetry. So I click on this formula card. So I know where my formula card is. And I'm looking for that negative 0.67, but I'm looking really for positive 67. So if you guys remember how we do this, right? Positive 67. My row for a Z is 0.6. Here's the row. And then I need the 0.07 column. Right there. 0.6 row, 0.07 column. We did all this yesterday. So I think we're here. It disappeared. There we go. So 0.6 row, 0.07 column. So I'm going to go here. And for some reason, yeah, maybe I think that's it. So maybe it doesn't let me write here. 0.6 row, 0.07 column. Where are we at? Files. All right, we'll just write it in here. I think I embedded it. So, okay, there we go. Point 0.6 row is here. 0.07 column is right over here. So you guys can see that, right? And we need to get a color that we can see. Find what's in the intersection of the 0.6 row 0.07 column would be. And if you take a closer look, it's right in here. So if you can see that, ladies and gentlemen, you know what that looks like to me? 0.2486. It's in the 0.6 row, 0.07 column. 0.2486. Now, that value, 0.2486, I'm going to write it down. That's a probability. We're using that idea of symmetry like we talked about yesterday. 0.2486, that means this is 24.86%. So to the left, you get 24.86%, and then to the right, you get 50%. Both of these together, we add, and you end up with 74.86%. So take the 24.86 plus 50. Is 74.86%. That's what percent of the ballot is shaded. That is what percent of the population has an IQ score. 74.86%. That's more than 90. So let's get rid of all of that detail. And let's just go with this 74.86%. That's how you handle a normal distribution question. Your first normal distribution question, ladies and gentlemen. This is every detail. You go through these steps. So you play what percent of the ballot is shaded, but with these particular, values of X and Z here. 24.86% have an IQ score above 90, more than 90. Now, here's something for some people, right? Some people say, boy, Mr. Judge, that's a lot of work. Those are a lot of steps. Yes, it is. This is about you following, like I said, a procedure, following steps of instruction. We went through every detail of every sort of step here. Okay, we've done the work. You just have to now go through this over and over again so you could do this practically in your sleep. And yes, on your test, I'll give you that table to use. Okay, so this is how we go about it, 74.86%. But if you said, listen, I have an TI calculator, and, I kind of like the functions and the features here. Can I use that? The answer is yes for those of you that have that. But I want to remind you guys here how to do this with the TI. You're going to go to the distribution list again. You're going to go to number 2 again. Remember, normal CDF. I need a lower value and I need an upper value. A lower value and an upper value. So I have to enter those in. So let me go back over here to the iPad, and let's remind you, go back to this picture here. Let's erase everything. I'm going to go all the way back even to the X distribution here, right? Read this left to right. This is the lower value. And then I ask you, what's the upper value going to be, ladies and gentlemen? If X goes from 90 all the way to what?
To infinity and beyond.
So the lower bound value is 90. You see this? And then we go all the way to what again?
To infinity and beyond.
So I need to have a big value for the upper value, because this goes all the way to what? Being more than 90,
to infinity and beyond.
Keeps going larger, larger, and larger. So here's what I'm going to say. Let's go back to the calculator and say, calculator, TI. The lower bound value is 90. My upper bound value has to be, again, what?
To infinity and beyond.
Okay.
To infinity and beyond.
I'm going to use a very big number. I'm going to use, how about 1,000? That's pretty big. All right, 10,000. Let's see if it works. So go all the way down here, ladies and gentlemen. Now remember, what is mu? If mu is 0, it's the standard normal distribution. Sorry, sigma is 1. That's the standard normal. In this setting, the mean was 100 because that was the average IQ score. That's mu. And sigma was 15. So, ladies and gentlemen, let's see what we get. This is a normal distribution. We're looking at these x values here. So mu is 100, sigma is 15. Let's hit enter. What do you guys get? We get 7475. Let's approximate this, ladies and gentlemen, to the nearest, 10,000s. So what we get now is 0.7475. All right, I'm just kind of curious here. Let's do this here. Let's go back. All right. So if I go back here to the iPad, I wrote down that number. I'm going to say something like this here. What you guys happen to find here, by definition, that's the probability that x is greater than 90 by the TI is 0.7475. This is notation. What that means as a percentage is 74.75%. Now, if you go back and you compare, you go, wait a minute, Mr. Judge, something might be wrong here. I got 74.86%. Well, maybe. Let's double check. Let me double check my Z value. 0.67, all right, is 2486.6. Okay, all right, that's still kind of off. I mean, wow. I wonder. Let me go back to the TI. And I got to find the TI now. TI, where are you? Here we go. I'm going to try this again. I'm going to say, I'm kind of curious. See this distribution? Go back down to enter 90. I'm going to use a bigger value. A really big value. How's that? Because that's supposed to be where?
To infinity and beyond.
And let's see what we get now. I'm just kind of curious. Oh, it's still 74.75. Okay. Well, I'm just going to let you guys know. Looks like there's some approximation errors here. I'm not happy about that difference. I want it to be the same. And here's what Sandra is saying. Sandra, so for the upper value, you can use any number over 100. Yeah, use a bigger number. But as you guys can see, it seems like that's the same value, right? More than 90. And I used a big number. I used, 1,000. And then I used, I don't know, maybe 1,000,000 or something. I don't know what I used. It's the same number. So it looks like that when they made this table, you know, in all honesty, there's numerical techniques that are happening here. There is an error here. So numerical techniques, ladies and gentlemen, have built-in errors, and that's why you see the difference. So what I'm saying is, on your tests and on your homework, could you use the TI? The answer is what? Anybody want to answer this question? Could we use the TI? What do you guys think? Let's see if you guys are awake and paid attention to this. Anybody know? Could you use the TI? Where is the answer to this question? I'll let you guys think about that. Let's go to the next question. Next question. They want to know. At least 120 has an IQ score. What percent of the population, here's the second question, that have an IQ at least 120? Right over here. At least 120 is X is greater than or equal to what? 120. So, if I go all the way down here, let's skip all this stuff. At least 120. Question 2. X greater than or equal to 120. Draw a picture of the question. $100's here. Here's a normal distribution. Oops. 120 maybe we'll put over here. And you have to know, what does at least 120 mean? It means 120 or more. So shade the portion of the bow that corresponds to these X values that are being here, at least 120. It's 120 or more. So you can follow the procedure I outlined for you guys here. Or you can use that TI here. Let's double check with the TI and see what TI says. Right? So I'm going to have to find out what this means here. So I'm going to say second, go down to the normal probability distribution. The lower limit now is 70. I'm sorry, not 70. The lower limit now, anybody know what the lower limit is? Let's go to the iPad. Right? This is the lower, and I have to go all the way to, again, what?
To infinity and beyond.
We're reading this left to right. Lower limit is
infinity
120.
and beyond.
Upper limit goes on forever. So when I go to my TI, I say, okay, TI, I want you to do 120 as the lower limit. And I got a bigger number here as the upper limit. Yes, we could use 1,000, 10,000, I don't know. As we've seen, it didn't make a difference. My mean still is 100 because this is an IQ score question. It's a normal distribution with a mean of 100, standard deviation of 15. So those are the same, and we paste it, and we end up with 0.0912. 0.0912. Okay, let's write this on the iPad. So here's what we have. 0.0912. The probability that the IQ score is at least 120 becomes 0.0912 to the nearest 10,000th position. What that means is, ladies and gentlemen, as a percent, though, it means that the percent of bow that's shaded is about 9.12%. So here's what you guys would have to do. Okay, 0.0912 is 9.12%. And this is how you actually go about some of these questions. It's in your book. Now, some of you guys are going to say, oh, Mr. Judge, I want to do the procedure. Okay, if you want to do the procedure, that's fine. Let's note. I want you guys to note that this is a right tail situation. So if you say I want to convert every X value now to a Z value here, so let me erase this portion. Here's a Z value. I know my mean will be 0. We did that already. I just don't know what 120 is when you convert. So I say z is x minus 100 over 15. Z will be 120 minus 100 over 15. So z is going to be 20 over 15. And in case you guys didn't know, z is going to be 1.33. So let's double check because I'm going to go to the TI. So you say, okay, 20 divided by 15 is 1.33. Sure enough. Okay, good. $1.33. So I have everything I need. But since this is a right tail, how do you find percent of the bow that's shaded for a right tail? You always start with the 50% and you always subtract what is missing. This is the right tail procedure. So you say, Mr. Judge, what's missing? I don't know. This portion is what? Missing. Whatever that is. That's why we use the Z table to find what percent of the bell is missing between 0 and 1.333. 1.333. Okay, so on my table here, Z is 1.33, and we have to write that as a row plus a column. What did we do yesterday? The 2 digits here around that decimal to the right and left, one place, that's 1.3. And then the column is a 0.3 because that 3 is in the 100th position. So I need the 1.3 row, 0.03 column. Okay, so let's go back and let's erase some of this. 1.3 row. So I'm going to look for 1.3 row. And I need the 0.3 column. So 1.3 row is here. 0.3 column is here. And let's use a little bit smaller. So 1.3 row. 0.3 column. And we can see a value of 0.4082 here. So let's see if you guys can see this. Looks like it's 0.4082 here in the table. 0.4082. Okay, 0.4082. So you say, what is this? 0.4082. That's not a percent. I got to use 40.82%. 40.82% is what's missing. That's gone. So I have to subtract 40.82% to get my final answer. So 50 minus 40.82% is going to be what's in the right tail. Let's see how close this is. 50 minus 40.82% gives you 9.18%. Okay, and let's see 9.18%. This is what we get using the table. And it's slightly off, and I don't like that it's that much off, but whatever. I like it to be very close. It's not. These are approximations here, ladies and gentlemen. You'd have to take Calculus 2 to really get the exact answer. You're going to approximate. If you did Calculus 2, yeah, I'm not sure which one. So anyway, could you use the TI on a test? Let's see. What does Catherine say? She says, yes. Good for you guys. Yeah, you guys can do that. That's fine. Joanna, what does Joanna say? With the tables is more precise. Is that true, Joanna? It's going to be, the tables are more precise? Maybe. Or maybe less precise. You see, the reason I think you might see these errors is because the tables only go out to the nearest tenths, 100,000, 10,000s. They go out to 4 decimal places. Your calculator here is a little bit more accurate. It doesn't go out to 4 decimal places. It goes out to a lot more, or can, in theory. It could go out to a lot more decimal places. And the problem is when you start doing arithmetic with approximations, you go further and further away from the actual value. In other words, when you approximate and you start adding and subtracting, multiplying, dividing, you actually go further away. The accuracy gets worse and worse. So I think the calculator is actually a bit more accurate, in all honesty. But, everything's approximate. We even approximated the z value. So either way, on a test, I'd be fine with. So just to let you guys know, I'm just throwing that out there. I mean, you can do it without it. People have always done it without it in my classes using your particular calculators. And then people have done it with the TIs. So I'm opening the door. I guess you can teach an old dog new tricks. I'm the old dog. Okay, so you guys know. That's me. Yeah, you can teach an old dog new tricks. And okay, I'll say maybe I'm just getting old. So yeah, you could use that TI. So let's look at the next question. No more than 135. What is no more than 135? Again, that's IQ scores less than or equal to 135. This is a bit different. No more than 135. So for those people who want to draw pictures, and I say draw those pictures, no more than 135 here. I always say draw a picture of the question. Okay. We moved. Okay. There we go. Ooh, again. Geez, don't even breathe, and this moves the line. The mean here is 100. 135 is to the right here. No more than 135, ladies and gentlemen. What numbers are no more than 135? Numbers to the left of 135. So we're shading the bell like this. These are all x values. So here's what we can do. Here's the notation. Let's put it a little bit lower. All right, now let's be careful here, right? If I want to use the TI, I need a lower bound value and an upper bound. You're going smaller to larger. So this is a bit different. Lower, upper. We call this negative infinity. The lower bound value is negative infinity. The upper is 135. As we read this left to right, okay? Lower and upper.
To infinity and beyond.
And it's actually minus infinity.
To infinity and beyond.
All right, so how do we enter this in the TI? Remember, the lower bound value. If I go to TI, okay, TI, second vars, normal. I need a lower bound value, negative. There's a negative, and you can put 1,000, 10,000, whatever. The upper bound value we said was 135. The mean is still 100. Standard deviation is 15 because we're doing the same setting, IQ scores. And here's what we get. Let's approximate this to the 10,000s here again. 0.9902. Okay, 0.9902. So here's our answer. However, that's probability. Okay, so as a percent, ladies and gentlemen, this is 99.02% of the population has an IQ score that's under 135. That's according to the TI. And then for myself, again, when we use the table, right, we can compare that value. All right, so let's now use tables, but I just use the TI here. You say, don't I have to convert every X value to a Z value? You do. You already know the mean of 100 becomes 0, but you don't know what 135 becomes. So you say, oh, Z will be 135 minus 100 over 15, or Z is 35 over 15. So 35 divided by 15, we get 2.33. That's the Z value. This is what we need to use to find the area that, or I should say, we find the area that's actually between 0 and 2.33, because by the tables to the left, we got 50% by the tables, and to the right, we don't know what that is. Now, that portion is not missing. That's not a missing portion. So we're going to add. So we're going to take that 50. We're going to add, but remember, 2.33 again, we have to look at the 2.3 row, 0.3 column now. So we got to find what to add. The 2.3 row, 0.3 column. You guys know how to do this by now. So let's erase. If it lets us. Okay, let's erase. Come on. 2.3. There we go. Oops. All right. Maybe it's not going to let us. It wants us to go back. Okay. I can see 2.3 row, 0.3 column. I can see here, it's actually going to be 0.4901 here. And there we go. Maybe it's under draw. It's 4901. Anyway, 2.33. All right, 4901. Let's go back here. So this portion, maybe I'll go be able to write in it. 4901. So if I take 49.01 percent, notice this gives us 99.01%. Now I'm happier about this because this is actually a bit closer here, right? Compare what we got. I like this a bit better. Compare what we got prior using the TI, which is 0.9902. 0.9902. So, ladies and gentlemen, using the table, we're a bit better with this approximation. So that's kind of interesting. But I want to go back. I don't like that. This is frozen. Whatever. Just want to get this out here. Let's see if it's unfrozen now. All right, let's go. The Z value 2.33, so we know. It's right here, just to show you guys. I wonder what page that is, by the way. 2.33. 2.3 row, 2.3 column. That's the value. 2.3 row, 0.3 column. So you guys can see 4901. So maybe I can't actually see the table correctly. That'll be weird. I might have to go back and double check some of those. That might be my eyesight. Oh my God. You know, it's not as easy to do this, believe it or not. So you guys can balancing the microphone and everything and blah, 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 blah. Anyway, here we go. Okay. So this is no more than 135. So it's pretty close. All right, let's try this next question. So what's the next question? Number 3. This is going to be what's the next one? Oh, between 90 and 120. Let's do a between. Between 90 and 120. Okay, so how do we write that? 90 less than or equal to x less than or equal to 120. So we're doing these as well, between 90 and 120. So here's the thing. Between 90 and 120, draw a picture of the question. The mean is 100 again. We just have to locate, right? This is a normal distribution. That's x. Locate where 90 is and 120. So 90 will be to the left of 100. And then 120 is to the right of 100. They want 1% of this bell is shaded. $90 less than or equal to x less than or equal to 120. Maybe I'll put it lower. All right, now remember, we need a lower limit value and an upper. So lower and upper. There is no infinity in these questions, ladies and gentlemen. X is between these two values, 90 and 120. So that's the lower and the upper value. Okay, so you guys know. So if I go to that TI now and say, TI, help us out. I want to clear this. Second distribution. Lower value is 90. Upper is 120. The mean is still 100. Standard deviation is 15. We haven't changed our setting. And ladies and gentlemen, this is 90 to 120. We get, if we approximate to the nearest 10 thousandths, we get 0.6563. 0.6563. This is what the TI says we get. Okay? All right. Now, let's compare that to using the table, because not all of us are going to use the TI. If we use tables, we need this percent of the bow that's shaded to the left. We need the percent of the bow that's shaded to the right. We have to convert to Z values. I got to know what 90 becomes, and I got to know what 120 becomes, because I'm going to use my Z tables. Now, 90 and 120 look familiar. Yeah, I think I found 120 as a Z value is 1.33. We got that one. I mean, I could do it again, but I got that one. What was 90? I think that might have been the first question. 90 as a Z value. What's 90 here? Oh, yeah, it's negative 0.67. So let's go back. It's over here. This is going to be a negative 0.67 here. I know the computation because I have it right here. Negative 0.67. Okay. And of course, the mean here of 100 is always 0. So I'm going to use the table for this left portion and the right portion of 0.67. Now, I'm going to use the table again because maybe my eyesight was an issue. So I'm like, let me go back to that table then. Right, 0.67. Let's find the z value for 0.67. So it's in the 0.6 row, 0.07 column here. So if I follow that, I get 2486. $24.86 again. All right, maybe I'm not imagining things. 24.86. So this portion is 24.86%. And then I got to go to 1.33. Boy, I really wish I knew what page that was on. 1.33. There we go. 1.33 now. 1.303. I see 4082. Okay, 0.482 there. 0.482, 4082. So this is 40.82% of the bow that's shaded if we use the z-tables. So finally, you guys know what we do. We got to add those values, right? So we say take the 24.86% plus the 40.82%, and let's see what we get. We get 65.68%. So 65.68%. So go back to the iPad and say, oh yeah, that pretty much does look pretty close, right? Earlier, this was the probability. This is 65.63%, right? So we compare those two. I mean, it's pretty close. So maybe, I don't know, maybe the first two questions I have to double check myself. I might be right. I like that a lot better. But as you guys can see, there's still some differences. So, it's not exactly the same. It's because this is all approximation. So this is how you handle using the z-tables to deduce your answer, as well as using the TI. So, the choice is yours. Okay, pick your poison. Some of you guys already went to OfferUp. Good for you. So you could use the TI-83 or TI-84. Question 5 here, less than 115, smaller than 115, so we know that. So let's say, okay, less than 115. Let's see what that looks like. Okay, we're doing this 5. So less than 115 now. Oh, thank you. 6562. Let's go back. Thank you. Yeah, it's off. 62. Okay. Less than 115. So we can say less than 115. Draw a picture of the question. The mean is in the middle there of 100 and 115 is larger, so it's to the right. Less than, or all the numbers smaller to the left here of 115. They're smaller than 115. They're all to the left, and this is a normal distribution, so you put an X. Now, if we say we're going to go straight to the TI, probability, X is smaller than 115, right? Let's see what this is. Remember, we have over here what?
To infinity and beyond.
Lower, upper. Lower, upper.
To infinity and beyond.
All right. So, okay, TI, let's clear you out. I want to find out, can you handle this? Second, lower again is a negative big value. The upper is 115. We get 0.8413. Okay, 0.8413. That's a probability. And that's the nearest 10 thousandths. So 0.8413, that's a probability value. But they ask what percent of the bow is shaded. So if they ask for a percent, ladies and gentlemen, give them a percent. All right. If they ask percent, give them percent. If they ask probability, give them probability. You give what's asked. So let's use the tables now. Right? I'm going to convert every X value to a Z value. The mean is 100. What's your conversion formula? Z is X minus 100 over 15. I'm going to plug in now 115. Let's see what this becomes as a Z value. 115 minus 100. Wait a minute. I don't have to use a calculator for this. What are we doing? It's 15 over 15. You guys know what that is. 15 over 15 is going to give you what? This is 1. So this is 1.00 if you want to look at it that way, because we're going to use a table. To the left, we have 50%. Nothing's missing here. We got to find what percent we're going to add. So I'm going to use that Z table. See what that is. All right. So we're going to go back to all the way to the end. Keep going to the end. Remember what the Z score is, 100. Here's our table. We've got to look for, remember the Z value, 1.00. Here's my row, 1.0 row. The column is 00. So, looks like it's 3413. 3413 there. 1.0 row, 00 column, 3413. 3413. So this is 34.13% of the bow that's shaded. So remember, we're adding here. Nothing's missing. 50% plus 34.13, we know is 84.13%. Oh, that's spooky. This is exactly what we got before. This is exact. Oh, nice. Anyway. Yeah, that's how we answer this question here. Both ways. Both ways. Let's try number 6. What are they asking for 6? Between 115 and 135. That means 115 is less than or equal to x, which is less than or equal to 135. Okay. 115 to 135. So we write this down. As an interval. Hundreds in the middle. Now 115, if you guys remember, ladies and gentlemen, would be larger. I'll just do it like this. And 135 is even larger. So we got to shade everything between 115 and 135. This is a normal distribution question. So written with probability notation, which is what the TI gives you answers to, right? We have to find what percent of the bell is shaded between 115 now and 135. So, all right, let's try this out. Let's say, okay, TI. Let's clear this out. Distribution, normal CDF. 115 is my lower limit now, and 135 is the upper limit now. So I want to remind you guys, we need a lower limit value and upper limit. Read from smaller to larger. Lower and upper. That's a lower and upper. As you read that left to right. Our mean is still 100, so we haven't changed the setting. We get 0.1488. That's a probability value. Of course, as a percent, that's 24.88%. So they're saying here that, I'm sorry, 14, not 24. They're saying 14.88% of the bell is shaded right in here. That means 14.88% of people have an IQ that's between 115 and 135. Okay, thank you, Catherine. Let's use the table. If I use the table, I got to convert everything. Remember conversion. Z will be x minus 100 over 15. So I already know what the mean is. It's 0. I actually converted 115 and 135 already. So let me go check this in our notes. Right? 115 and 135. Oh, 115 is right here. It's 1.00. 135. Let's find 135 now. I seen that earlier. Oh, here it is. It's 2.33 right here. Now, if you guys recall, I need to get the bigger area minus what is missing here. Oops, we don't want that erased. This portion's missing. So here's how we find this. It's the big area minus the missing. The big area, though, is between, well, we're going to use the z-values, is between 0 and 2.33, right? And what's missing is between 0 and 1. So this is how we did this in the past. So I need the area between 0 and 2.33. I think we have that already. We don't have to look at the table here. So 2.33, let's go back here. I think we have that. We have that. Here we go. Yeah, it's 4901 right here. We did that one already. 4901. So I get 4901 here. And then throw out what's missing. So you say, well, what's missing between 0 and 1? And we found that here. What was it? Oh, no, that's the same question. 0 and 1, sorry. It's right here, 34.13. 34.13%. There we go. Go back if you missed it, right here. Right, from 0 to 1, 34.13%. That's the portion that was missing from the prior examples. Prior problem. So we just have to take this difference and see what this is. And we have to go to the TI and say, TI, take the difference of 4901 minus 34.13. Let's see what we get. 14.88%. Wow. Right? 14.88. So if I go back and compare with the TI, that seems to be what we got earlier, meaning we got this answer earlier, 14.88%. So ladies and gentlemen, this is how you handle these questions here. When you use the Z table and when you use a TI calculator, I should say when you use a Z table and any calculator versus just using the TI alone. So ladies and gentlemen, these are the kind of questions that you're going to see on your test here. So be prepared to do them. Now, I already gave you guys homework questions on this. You have web questions and you have book questions. So if I go all the way back to the homework, you go 6.1, 9 to 39 odd. Yeah, we're going to keep with that. And you're going to do statistics lecture 12. That's the normal distribution questions. So continue with this homework like you guys been doing. But this is how we deal with the applications. And ladies and gentlemen, yes, this is going to be on your test on Monday. So whether you're watching this now or you're watching this later, I want to remind you guys here, you're going to have to work on being functional at home with your scanning software. You're going to use a formula sheet, of course, that I give you guys here. And then you're also going to have your Z table sheet in case you need it. And, start to think about how you manage things and get things together. So we're also going to have to turn in some homework, and I'll give you some announcements about the deadlines. It's going to be before your test. So that's how that works. And like I said, we're starting to become more efficient and effective with this environment. We're forced to, and we're forced to adapt. We're forced to overcome. And this is why I'm allowing you guys to use some of these tools as well. Okay, like the TI-84, TI-83. So I want to wish you guys a good day. I hope you guys stay safe. And if you have any questions or issues, of course, come to my office hours. If you can't get in, email me and I'll let you in. All right. And we have Sander. Am I going to give you a study guide? Yes, I will. But I want to remind people here, just to let you guys know, I'm talking from experience here on tests. you got to be very careful. The best thing you could do on any test is to prepare. I know it sounds obvious. Not everybody does. People look for shortcuts. Like, I don't want to do all that work, Mr. Judge. Oh, I got to write this down. Yeah, you got to do it. The only way you move forward is to go through things the way you're supposed to go through. Right? The biggest obstacle to progress is ease. So, yes, I'm going to give you guys a study guide. Some people just say, I just look at the study guide, and that's all they do. They don't look at the lecture. They don't do any homework. And that's the kiss of death. They go, why don't I learn? This is hard. Because you haven't put yourself in that learning mode of being being uncomfortable, going through steps, pulling your hair out, figuring out what's going on. So I want you guys to do that, all right? And so thank you guys. Yes, have a good day. Thank you, Cassandra. Thank you, Catherine. All right. Thank you, ladies. Have a wonderful day. Stay safe. And I'll see you guys tomorrow. Take care.